are going to discuss more functions about or the generating numbers and making data sets. There, we have discussed few techniques or few functions that are helpful to create data sets. And now today we are going to discuss new way. So some another methods that we can store data before the analysis. So here matrices are the next type of objects that we can define to store data. So it's just simple function. You can call matrix, and inside the function matrix we have a few more arguments, and you can see here we have first argument is the vector or the sequence that we want to input to the matrix, and we have defined the number of rows and number of columns separately. But here it is okay to mention only one of these, which means if we give the number of rows, automatically the function will adjust the number of columns by taking the length of this vector and dividing it by the number we are giving. So if we gave row, so then it calculates, or it will calculate the number of columns and automatically give the matrix. So you can see it is stored here with few description. By clicking this, you can see a separate window. These are the variables, and so these are treated as variables. So columns are treated as variables, rows are treated as observation. So or you can call, so when you are clicking this, you can see you are calling the view function. So that is another function that we can use. So view m1 means same function which is automatically called by clicking this. So that is why we are using this interface. So it has some built-in operations that we can do manually if we used R only. So that is the basic way of creating matrices. For matrices, we can give the numbers, and for the numbers, we can give the numbers in forms of vectors. So here, just type the set of numbers, or we can define the vector first and give the vector name to here with proper arguments. So apart from that, we can, so if we type m1 here directly, it is printed here. Now it is not treated as a data set, it is just a matrix. So you can see this is the first row, all columns, and this is all rows, first column. That is how this is important when we are doing scooping. So we have to get familiar with this. In the box bracket, first part or first space is for rows, and it is separated by a comma, and the second space is for columns. So this is the observation 1, 3. This is 4, 3. So likewise, we can uh, identify the observation by a grid using the number of rows and number of columns. So we can give names for these columns and rows separately. So I am creating string vectors like row names. It is R1, R2, R3, and for column names, for I call it as CN, my objective name, and my vector includes C1, C2, C3, and C4. And I'm creating the vector or the matrix M2, and that matrix has numbers from 1 to 12, and number of rows is 3, number of columns is 4, and I'm giving another argument, that is by row. By default, by row is false. So if we, which means we are giving the instruction to the computer to arrange this vector by rows. So you can see here we didn't give by row command. So there this vector contains integers from 1 to 20. So you can see 1, 2, 3, 4, 5, 6, 7, 8. So the sequence is arranged in the vector in the matrix form by column wise. So it starts from one cell, it goes to the next row, and fill the first column. After filling the first column, just move to the next column and start with 1, 2, and go to the bottom of the column. Likewise, it's filling in column wise, but giving by row true, which means it fills in row wise 1, 2, 3, 4, likewise. And the dim names. So dim names means the dimension names. So I have defined these vectors before. I know that I have uh, 3 rows and 4 columns. That is why I have 4 names for column names and 3 names for row names. So I am giving row names first and column names second. So that is why in this bracket also, first number is row, second number is column. So I am executing that. And after that, I can see it is dim2. Dim2, dim2 means dim function is to find the dimensions of the matrix. So I type dim, and within bracket I have to give the matrix name. So here it is M2. So then it has 3 rows and 4 columns. So it's just the matrix uh, notation we use in mathematics. So they are also, for the size of the matrix, we write down number of rows by number of columns. So that is the order. If you want to see only the column names, so we can type column names, and we have to mention the respective matrix inside the function. So it will return the column names. And if you want to get the row names, you can see this here. So let's see, we can go get a summary of M2. So now you can see each column is treated as separate variables for this summary function, and it consider as C1 as one set of data, C2 as another set of data, C3 as another set of data, which means these are four data sets in one data set. Oh, yeah. These are four separate data sets and they have combined four data sets into one file. So it's like same manner. So here give the minimum number, first quartile, median, mean, third quartile, and the maximum number. So just a simple descriptive statistic output is given for the summary of M2. So M2 is a matrix, which means taking the summary of a matrix always give the summary measures of each few summary measures of each column by treating each column as separate data sets. Now we can see how to edit or change or add column names or row names in a separate way. So here we use column names function to return the column names of the matrix. So here I'm using that function first, which means I need to change the column names of M2. So I'm calling column names and assigning new column name. So I am defining new vector with four names or four strings. So now I'm storing this vector or I'm assigning this new vector to the vector returned by this. So let's see what's happened. So I have assigned that one, and if I can call M2 again. So now you can see previously we had C1, C2, C3 and C4 as column names. So here now my column names are MC1, MC2, MC3, MC4. So you can check that names M2. So now my new vector is overwritten on the previous vector. And so that is a important thing. You can overwrite the same vector. So overwrite on the same vector, which means if you are using the same name, your data will be loose. So if you are using the same name for two different vectors, first data will be, or the first vector will be override by the second assignment. Always the second assignment will remain. So please be careful when you are using names for objects. And here, if I want to, so this dim2 return the dimensions of M2. So it is 3, 4. Now I want to change the dimensions as 4, 3. So I'm giving that, and let's see what happened to the vector. So initially it was 1, 2, 3, 4, and like that we had here. But now by shuffling this, we had a new matrix, and you can see that it has 4 rows and 3 columns. But the data is same, but they are in a separate order. So here first one is 1. The last one is 12, or the 4, 3 is 12, 1, 1 is 1. But apart from that, you can see 1 here, 5 here, 9 here, and after that 2 has come to this. Then 6 is here, 10 is here, which means it takes this matrix as a vector by combining columns. So 1, 5, 9, 2, 6, 10, 3, 7, 11. Likewise, it just join these three after this. So join this, start from these three, join these three after this one, again these three and these three. So now we previously we had numbers from 1 to 12. Now that order is missing. The new order exists, which means 1, 5, 9, 2, 6, 10. Likewise, we have 12, and the computer used that vector to create the new matrix. So using that vector created a new matrix of 4 rows and 3 columns. That is why 1, 2, 3, apart from 1, 2, 3. So it is, you can see 1, 5, 9, 2, 6, 10, and 3, 7, 11, 4, 8, 12. So that is how a vector is created. So when you are changing, so these kind of things, you have to have an idea what happened inside the process. So now we can move to generate a vector of sequence of unequal lengths. So previously we discussed how to create sequences with equal lengths, and the sequence command. So I'm using a vector inside the sequence command. So now you can see I have given the vector 4, 3, 2 inside the sequence command. Let's see what's happened as the result. So you can see that 1, 2, 3, 4, 1, 2, 3, 1, 2, which means the sequence command has created a sequence of with the unequal lengths 1 to 4. It repeats, or it uh, create a new sequence from 1 to 4, and then combines 1 to 3 and 1 to 2. So all the integers are arranged and always start from 1 and end with the first element. Again it starts from 1 and ends with the second element. Likewise continues to all elements. So then you can see the sequence is created in unequal lengths. And even with the repeat function or rep function, you can give. So this is my data set 1 to 4, and I want the pattern 1 to 4. Let's see what happened. So there, first number is repeated for 1 time. Second number is repeated for 2 times. Third number is repeated for 3 times, and the fourth number is repeated for 4 times. So if I change this, you can see here. My data set is 7, 8, 9, 10, and I want those numbers to repeat in unequal lengths. So I need 1 7, 2 8s, 3 9s, and 4 10s. That is why I first give the data set, then I'm giving the sequence or the order of repetition. So that is somewhat systematic. But if we want to have another pattern data with unequal lengths of repetitions, so we can see, just give the data set first, and in a separate vector, or the vector I am giving to this place, can have the number of times that each element should repeat, which means I need 3 ones. So if I call like this, C 10, 20, 30, and 40. So now I need 3 10s, 4 20s, 1 30, and 4 2 40s. So I can get that equivalent sequence. So here you can see the error in here. So that is because I have used capital C. So see how it is easy to create codes using RStudio. Whenever I am doing a mistake, it will give the error, and I'm executing it after re-checking the code. So that is an advantage of RStudio, as I mentioned before. So now you can see how to create factor levels or sequences with unequal repeated lengths. And vector is also a matrix. So we created vectors first. So vector is a row matrix, which means it has only one row and several columns. So calculations using matrix can be done uh, easily as the according to the mathematical concepts, which means addition and subtraction. You have to have two matrices with equal size, and you can perform the matrix multiplication, and you can get the matrix transformation and inverse. So here we define two matrices called M3, and you can see the data set I want to input there contains only zeros and ones, which means repeat 0 and 1 for 6 times. So using the functions inside functions. So, and the number of rows, I'm only emphasizing the number of rows because automatically it will calculate number of columns by using the length of this input vector. So again, I'm creating M4 by giving this sequence and arranging it for 3 rows and 4 columns. After that, we can perform addition, subtraction, and for multiplication, it's like this. So normally, to multiply two integers or two numbers, we use asterisk mark. If you use asterisk marks for matrices, so you have to you can multiply each corresponding element of two equal size, equal dimension matrices. So here you can see what happens to the elements. So just first element is C. So this is M5, so it is multiplication of M4 and M3, which means multiplying the corresponding elements 1 by 0. So it is 0. 4 by 1. So it is 4. It is 3 by 0 by 0, 10 by 1. So it's multiplication of this one. This is the result 0. 4 by 1 is 4. 0 by 7 is 0. Likewise, each corresponding element is multiplied. If you use asterisk only. To get the matrix multiplication, you have to use this symbol, which means percentage asterisk percentage. And you know that to multiply two vectors, we should see the order of or the dimensions of the matrix like this. First matrix should be M and N, and the second should have N by M. The dimensions should be M rows and N columns by N columns, N rows and M columns. So if this happens, then we can perform the matrix multiplication. This is not the metric multiplication, just multiplying the corresponding elements. So you can see for the matrix multiplication, perform without any error, and this is the result. So this is the matrix multiplication. This is just multiplying the elements by the other things, because in R we are using it for statistical analysis. For in here you saw that even matrices are considered as data sets. So each column contains separate variables. So sometimes we need to consider the whole data set as a matrix. In that case, in regression, so we are calculating the coefficients of the regression or regression coefficients, then we are treating these sets as matrix. But sometimes we are just want to get the corresponding multiplication, so that is why they have provided two types of multiplication. So just the simple multiplication and the matrix multiplication, and the transpose of a vector. So it is just T and give the vector. So you can see M3 has 3 rows, now M3 has 3 columns. So it is the matrix transformation, and we can take uh, the inverse vector by solve. So this is the inverse of matrix 6, and we need to get the determinant of matrix. So then it is det function. So using that det, you can have the determinant, and even using the determinant and the adjoint matrix, we can find the inverse, but we have direct function called solve. So solve gives the inverse directly. So you can find in the internet or in any of the text resources to get the coefficient or adjoint of a matrix. How to get a adjoint of a matrix using R, and if you have the adjoint, then you can divide it by the determinant, and it gives the inverse. So those are the some extra things about matrix calculations. Now we can move on to some factors, how to create factors. So factors are categorical variables that have fixed number of levels. So now we discuss some object of R. So factors are like this. So gender is a factor. So it has only levels. So now we can use factor command to directly give the factor. So if you input this vector as it is assigned as an integer vector. But in our analysis, if we use 1, 2, 3, and 4 as factor levels, so then you have to call the function within the factor function. We call the vector within the factor function. So here you can see 1, 2, 3, 4 is a set or data set, and it is a factor. So that is why they have listed all the factor levels. So if we call the factor function like this, automatically they will assign all the appear distinct values as factors, factor levels. So here you can see A, B, C, and D. So if I put another A here and execute it, I have the data set here A, B, C, D, A, but I have only 4 factor levels, which means automatically it grabs the distinct values inside the vector and consider those distinct values as the factor levels while it redefining the character vector as a factor. So GL function also provides some platform to calculate or to create factors. So in some data sets, we have more factor variables. We have to enter those things in a systematic way. So we can see that GL 4 3. So here you can see by giving 4, it says I need uh, a factor variable and use the levels uh, as 1, 2, 3, 4, which means by giving 4, it gives the argument take the factor levels from 1 to 4 or the integers from 1 to 4. And 3 means I want to repeat each factor level for 3 times. So uh, last lecture I showed you how to get the help menu. So by taking the help menu, you can see what are the arguments and what are the things you can do using this GL and the factor function. So now here, if you want more, so if you want a factor variable with these 4 factor levels with the same repetition pattern, and I need to repeat the same pattern for more times, so then I can give the length of the factor vector. So I need factor variable with 1, 2, 3, 4 factor levels, and I need to repeat each factor levels for 3 times, and the length of that factor vector should be 24. So here if you can see, automatically it will give the length of 4 times 3. But if we emphasize 24, which means it repeats 2 times. The same pattern repeated for 2 times. First, they make a pattern using these two and repeat it until the end of, or it meets the length requirement. So you can see here the same thing repeated for 2 times. Now we can create more factor, which means here we only use numbers or directly strings or characters, but we can create factors with names. So here you can see GL calls, which means in 2 means I need 1 and 2 as factor levels, and I need to repeat each level for 2 times, and I need the factor vector uh, with length of 12. And by giving the label argument, I can give this name or take this name or string as the first factor level and take this one as the second factor level, since I have used 1 and 2 for factor levels. So that is why I gave this. So let's see what's happened. So here, instead of 1 and 2, so here if we go back to this place, it repeats only numbers since we gave numbers here. So I gave my factor levels as the integers from 1 to 4. But here I give the same argument, but giving labels, this function assigns 1 or assigns low to 1 and high to 2. So if you give labels, so it automatically assigns those strings, those names to the factor levels uh, according to the order that you have entered. So the order is important. So now you can see it has only 2 factor levels, low and high, and the data set is like now. You can see it is low, high, low, low, high, high, like that. Same pattern without the numbers. Instead of numbers, numbers are replaced with the factor labels we have given. So in here, I ask them to create or consider 1 or 4, 5, 6, and 7 as a factor vector, and the labels of those factors or the levels of factors are A, B, C, and D. So let's see what happens. So there, instead of repeating the numbers or displaying the numbers, they have, or the computer has written only the levels, which means first number is 4 and it is considered as the level A. 5 is considered as the level uh, B. 6 is considered as level C, and 7 is considered as level D. So you can see that though we gave the numbers there, by giving this label argument, it assigned all the strings or names inside it according to the order of the case, which means it consider only the position of the data point in the vector we are giving as the factor. So we can create more types using this factor function. Um, so here it's only assign the labels, and you can see how to deal with this GL function with in the R help menu and R blogs. So there, factor 1, 2, 3, 4. So we need, so this is the data set, and I asked the computer to consider this data set as a factor variable, and the levels of the factor is now goes from 1 to 5. So here you can see our data set only has 4 observations, but this variable can have levels up to 5. So factor, you can see the difference between this GL and factor function. So the types of factor variables that are created using this GL and factor functions separately. So they will create different types of factors. So here now you can see factor consider this variable or this data set as a factor variable, and the labels are A and B only. So you can see that the data set is ABB, and A and B are the factor levels. So here, now I'm asking or using the factor variable or factor function, I'm asking the computer to consider this 1, 2, 2 vector as a factor. But I'm giving the levels in a character string. So let's see what happens. So though it takes the levels as A and B, these are undefined or not assigned, since these are integers and these are characters. But in GL function, we can give numbers as the input and assign strings for each number according to the order we are giving in the argument. So that is the difference. Now, I have given some additional information about creating factors. So I took this from the help menu of R. So you can use help factor, or which means question mark factor command in the console, and go to the help menu, and there you can see this example is there with many other examples. So scooping letters from a string is another part that I found from that example. So before going to the example, I need to introduce this substring and subster command. So it just scooping letters from a string, which means suppose this is the name of the person, or this is a factor level, or this is a string, and you need only the second letter and the fourth letter from this string. So you can see uh, it returns the number or letters from second to the fourth letter. So you can see BCD is printed. So which means I ask the computer, this is my string. From this string, I need to get the letters from the second, third, and fourth. Which means to start. This is the starting position. This is the end position. All the positions. So all the string characters between these two positions, including the boundaries, will be returned using this substr command. And now substring is another type of scooping command for characters. Suppose statistics is the string I need to uh, consider. So I'll give starting point as 1 to 10, end point as 1 to 10. So see what happens. So it separates all the uh, characters from the word I have provided. Why I gave 10 is there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 characters inside this statistics word. So I asked the computer to consider the characters from 1 to 10, and I need to return all the characters 1 to 10. So likewise, you can have different combinations and see the output and try to understand the behavior of this function. So now I can go forward about these factors. So table command can be used to summarize uh, the factor variables. See, this is my vector. I need to get a summary of this vector. So I run the table and the vector. You can see I have 4 ones, 4 twos, and 2 threes there. And even it's work for characters as well. So here you can see I have 2 m's and 1 n. Now creating factors. So using these two functions, I can create another type of factor. So here I create a factor, and my input is the word or letters of statistic word, and my levels are letters. So these you can see that by giving letters, I mentioned it earlier as well. So the letters word in lowercase letters, it contains, or it is a vector with the lowercase alphabet. So my levels has 26 levels. I have 26 different levels in simple English letters. So my input has only 10 strings, or 10. My input string has 10 characters. So there, this is my input. This input is factor variable, and that variable can have 26 different factor levels. So calling a table, you can see I have 1a, 1c, 2 i's, 3 s's, and 3 t's. So there is a summary of this factor level. So you can see, since I have 26 factor levels, the absent factor levels are given by or indicated by 0 frequency. So just simple as that. So now I can convert this. So this is cohesion. So I'm discussing this cohesion part in the next uh, lecture. So just see, uh, you can see here ff has characters. So by converting characters using as integer command, it will say, so S is the 19th word, T is the 20th letter, A is the first letter, again it is the 20th letter. Likewise, it gives the position of the letter in the alphabet. So now I create another one using this factor. Now there are only, though I have 10 letters in the word of statistic, I have only 5 distinct letters. So others are repetitions. So I have only 5 levels. A, C, I, S, T are my factor levels, and those are mixed in the statistics word. So this is scoping. So the same thing can be done instead of this. Same thing can be done using this function. And here the table left gives only this. Now previously I had 26 factor levels. Now I have only 5 factor levels. That is 5. So the table is given like this. So we have to identify that this function gave a different kind of variable, and these two functions gave another different kind of. So these are not same, though we have used the same word with same letters. The way of defining the factor will make two or more different kind of factor vectors. Now we can come to the data frames. So data frames are more general than matrices, as different columns can have different classes of data. So even in the matrix, we had only one class. So if it is, so we have used integers, so then it is integer matrix. So if we have used real numbers, so it contains only real numbers. But uh, in more general data set in the real world, we have different types of data variables. So that those variables can take all 5 types in different times. So I create 3 variables first. V1 is an integer vector. V2 is a string or character vector. There I have used NA, which means it's a missing value. So suppose the data entering operator has made a mistake of typing that in the raw data form. So we are importing those things in handwritten papers to the computer by hand. So that's why that is missing. So I assign NA, not assign uh, operator to this. And the third one is logical vector. It has only true and false. Now I am creating a data frame. So this data frame can contain different type of objects. So this is integer, this is character, and this is logic. So I combine all 3 in this way, which means first column has v1 vector, second column has v2 vector, and the third column has v3 vector. So that is the order. Create the order that we give. So there, by clicking here, you can view the data frame. So if you can see, this is the variable 1, 2, and 3. And the missing value is they are integrated by NA. So like I mentioned in the matrix case, this V function can be used to read the entire data set, though it is whether it can be a matrix or data frame. So here we have v1, v2, v3 as the variable names. Now I want to give proper variable names according to my data set. So those could be ID, item, and quality. So V1 is ID, V3 is item, and V4 or V3 is quality. And the names of data file, this function names function will return the names of the data column names of the data frame. So in my data frame name data file contain 3 columns, and the names of those 3 columns are v1, v2, v3. So I call that into my environment. Now I am assigning new names for the called all names. So I am assigning ID for V1, item for V2, and quality for V3. So let's see. After defining that one, I can go back to this open one. So automatically, these V1, V2, V3 is changed according to the assignment I have made. ID, item, and quality. So that is the one of the advantage of this interface. You can see. So having an additional script file here. Now using this str, we can take a quick summary or quick look at snap on the data frame. So you can see this is a data frame or data file is a data frame. So that is why it's mentioned here with 4 observations and 3 variables. So it is a general and it gives the names of the variables then and give the type of the variable. So it is a numerical, the second one is a factor, third one is a logic, and it gives few observations in the variable. But the summary gives, so we call that summary function in matrix as well. It consider uh, each column separate variable. So this is more meaningful in data frames because in matrices we there this summary and the weave considered each column as separate variables. So but sometimes it cannot be or it cannot be true. But in here we know the columns of a data frame contains different type of variables. So it is meaningful in this place. So summary gives ID. ID is a numerical vector, so it gives the summary measures for ID. But item is a factor, so it just gives the table of each or the frequency table for each factor. We have one bread, one butter, one jam, and one mayonnaise. And this for logic as well, it gives a table. Mode is logical, and we have one false and 3 truths. So it's easy, and I can see that there is a NA, which means if I am able to find the correct value for this NA, I can edit the data file. How to edit the data file? You can call the edit function and name the data frame or use the name of the data frame here. So my data frame is now data file. So by calling that, it gives a separate window, and in that window I can type the missing value and enter, close it. So you can see my addition is recorded in here. Since I didn't store that one to the data file name, this place wasn't changed. So to do so, I have to rewrite on the same variable name. So it's like this. So I need to rewrite the data file with the edited data, or by editing the initial data file I want to rewrite the previous data file. So there, I put cake here, press enter, and you can see this place is changed now. So you have to assign to the previous name if you are using the same name. So edit function allows you to edit the data frame in a separate window. That is quite easy. Now I can move on to add columns and add rows to matrices and data frames. So you can see matrices and data frames are similar. They have a grid, but the difference of the data frame from the matrix is the way the columns of the data frame can contain different types of data. So here I'm creating x1 vector, and I want to, if you can remember the M2, here M3, it is a matrix with 3 rows and 4 columns. So I want to add one row to that M3. So first I call the rbind function, and I need to attach, or I need to update M3 by this vector. So I am adding this vector x1 to the bottom of M3. So you can see now my x1 is added to the as the fourth row of M3. So it's quite simple. And now you can do the same thing for the data frame, adding one row. But suppose I need to combine two similar data frames. So in the previous one, I defined v1, v2, v3 as variable names and defined the data frame first, and then I assigned the names for each variable. But that this is also possible, which means type the name as it is. So my vectors contains now the actual names of the columns, and when you are defining the data frame you can call these variable names. So these variable names are automatically assigned as the column names. So you can see data file 1 directly get the names that we use. So now I want to create a new data file. So update data file by joining the data file 1 to the bottom of the first data frame. So that order is important. This is the data frame that you want it to be on the top, and this is the data frame that you want to be on the bottom. So I execute that here, and you can see data file 1 is this, and data file is this. So our new data frame contains these 4 rows followed by these 3 uh, rows. So new data frame has 7 rows. So that is how to update rows. So now if suppose if we want to uh, update or add columns to the matrix or a data frame. So I create a new vector here, and I join that vector to the previous matrix M3. So you can see previously I had 4 columns. Now I attach that C, or the new vector as a new column to my matrix. Now we can see uh, how to add a column to a data frame, which means column to a data frame means adding a new variable to a data frame. So suppose it is a status. So the name of the new variable is status. It's a factor with two levels, old and new. I repeat, one for two times and two for two times, which means old for two times and new for two times. And I am using the cbind. I attach that the newly built variable as the last column of the data frame. So order is important. I am saying it again. So you can see now my added column is listed in here. Now the or we can use the definition or defining function data.frame, and you can have a data frame first and then the variable second. So it is also possible. And there are so many other functions to do so. So you can find those things in the internet and our blogs. So you are free to use those functions uh, in any occasion in this course. Um, Now we can move on to list. So there we discussed that data frame can contains different type of variable or classes. In here, lists is similar to vectors but can have different classes of data. So first, we had different, in the data frame we had different data variables, but list is a uh, type of vector, but even in the vector definition we can't have different type of data inside vector definition. But defining a list, we can have characters, logics, and numeric data and data frames. Any type of uh, data can be attached to a list. So it is like a vector containing different type of data. So you have to emphasize those things in like in arguments. So here my list is W. So I'm giving name as Pereira, number as 5, matrix. You can use any argument here because you are the person. So you have the freedom to use any kind of argument. So it will keep the argument you use in the computer memory. So list is the function. So inside the list function, you can have different type of arguments and you can input different type of strings or numbers or logic or matrices or data frames, any other uh, data file under list, and you can use your own argument names. So here I set that here. Can see object D not found. So I haven't defined D first. So I can drop that one. My vector is, I had a vector they are called x2. So I'm attaching that x2 to here. So now you can see W is a list. By clicking that list, it is visible here. So B function is works for list as well. So now you can see under W, I have 5 type of things. Name, it is a character and it is period. My number is a double and it is 5. My matrix is an integer matrix, it is 4 by 3, and these are the values. And you can access these things separately. So here my age is a double again 30. My vector is an integer vector and it is this. So you can have different type of data inside one variable name. So list is a function that allows you to do so. So in here you can see my next list is this V, and I can combine two lists. This is just again define, it is just similar to defining a new list using the list function. You have to uh, enter two lists according to the order. So, which means I need a new list follow start from the W and ends with V. So it is like this. So my new list is, I have under my list I have name, my number, my matrix, my age, my vector, my city, my distance. So different types of data sets are combined to one name. So you can see in the output there's a dollar mark. So which means this dollar marks enables you to extract data from a list. So W is the list name, and once you type the W and the dollar mark, computer suggests these are the data types that are available under W. So I need name and run. So it returns only the name. Or you can this scooping. So we are discussing this scooping techniques in the next class. So you don't have to worry about the techniques now. So you need to you can see this output or printed in here. So this one list under the list name double bracket 1 means dollar name. So if you want to get the name, you have to write the list name and double bracket 1. It will directly give the name. So likewise, if you want to get the city, you can type the name instead of the number inside the double bracket. So it is Candy. Now you can see the class of the object using this class function. Suppose we have different kind of data, and I want to check whether the class or no the class. So class W is a list, the class of x2 is an integer. So you can see list is a separate class or the object class. Now at the end of this session, I'm introducing this equality. So all the iterations or the calculations are doing according to the machine. So each machines have two different machine errors. So according to the machine errors and process times, for the same operation, we will get different numbers. So you can see square root function return the square root of a number. So square root 2 gives or supposed to give the square root of 2. So I'll assign that one in capital X1. So according to the mathematics, square root times square root should give the number. But in here, x1 times x1 equal, I want to check, equal 2. That is my logical. Okay, so we are discussing these logical operations in the lecture. So you can see it is false. Why it is false? So I can see square root times square root minus 2. So square root 2 times square root 2 should be equal to 2. But my machine has an error equal to this. So it should be capital. Since I have a vector there. So this is the machine precision of mine. So taking square root as always a greater than or greater value than the actual square root. So that is depend on the machine. So your machines will show different numbers uh, sometimes. How to get rid of that? So we can take here also you can see for the fractions and real numbers, the accuracy is lost due to the round off error. So using all dot equal function, I ask the computer to consider square root or any other calculation is equal to a known value in mathematical. So now I need to take the second power of the square root 2 is equal to 2. So then I ask the computer to take this into its memory. Square root 2 times square root 2 equal to. So by that will be assigned using this function. Now it is true. But always try to avoid testing equality with real numbers because there is a round-off error. So that is the end of the lecture today. So you can practice more examples. I have just covered the areas that I have to introduce to do calculations in the upcoming parts of the lecture. So you have to practice this, be familiar with R. So there are plenty of examples and exercises that are freely available in the internet. So you can use those things and get familiar with these functions. And apart from these functions that I have listed in the lecture note, you can find many different kind of functions to perform the same uh, task. So you are free to use those functions inside any code or any task. So, but you should do it in meaningful way.